No, Stella was getting tested last night, and I stood right next to her in psychology, and I literally started crying. I was like, I cannot get quarantined again.
That was like a bunch of the people that got quarantined again were like, I'm still trying to catch up to the last time.
Yeah. Exactly. They are. Yep. Okay. Well, we finished up the first part of 12, which was a lot of trig identity stuff yesterday, right? And there was a lot of how do you derive one from another. And now we are going to look at logs. So, log form, log base b of n equals p. That's the log form, and that can also be expressed in exponent form of b to the p equals n. Do you remember the connection between these two? Yep. This is the left-right middle thing, or as I often abbreviate, LRM. Okay. So this is the left-right middle that if it's in log form, you can do left raised to the right equals the middle. I also try and remember that the base of the log is the base of the power over here. And then you switch the n and p. It's like this base now has this power. I don't know. You have your way you remember it, right? Okay. We can also use the change of base formula to change difficult bases to natural logarithms, or even log base 10. Okay, so change of base formula is log base b of x, and the way they have it written here is natural log of x divided by natural log of b. Really, the change of base formula, you can use any base, because we can also see this done with common logs, where it's log base 10 of x divided by log base 10 of b. Okay, so either way, but do be familiar with your change of base formula. If you recall, there is a way on your graphing calculators to change the base as well. But there are times that the change of base formula is helpful. Okay, like, not in just finding a log, but in like solving an equation or something maybe. Okay, so I know it can be found in one of your alpha menus, but if all else fails, it's in the math menu somewhere. Okay, so we're going to sketch the graph of some log functions. Do you remember what a log function graph looks like? Do you remember what an exponent function looks like? Yeah, exponent function. I don't know, I think Ethan swooped the right way. That's your exponent, right? Like, this is like y equals e to the x. Now, because exponents and logs are inverses, the log function is reflected over the line y equals x. And so if you take this exponential function and you reflect it, it now becomes something like that. And this is your log. Okay? So we talked about that at some point last year in pre-cal. I don't know when, but at some point, right? Now, if we want to sketch a graph and we want to get some specific points for this, and, we don't really, we're going to kind of assume, log base 4, okay, say our calculator doesn't do that. We can take this log equation and change it to what form? We could.
Or we could just do left, right, middle.
I was just trying to think of the ramifications of, I'm not going to say it's a no, but to me, easier would be to think of a left, right, middle. And if we do left, right, middle, now notice the log equation's on the right instead of the left, yes. So my left is over here now. But the exponential version of this is going to be 4 to the power of y equals x. And if we're trying to do an XY chart, and this dates all the way back to Algebra 2, really. If we're trying to do an XY chart, normally on an XY chart, we what? We pick our X values and substitute them in to get our Y values. What do you notice about this problem? Yeah, we'd rather pick our Y values, right? So if I instead fill in -1, 0, and 1 on my Y values, that gives me an idea here. So if we put in -1 for Y, what? Yeah, 4 to the -1. Remember to make a negative exponent positive. We move it across the fraction bar. So that's 1/4. 4 to the 0, 1, and 4 to the first, 4. Feels weird filling in your X values that way, I know, but I agree.
I do remember doing something with that before. Like there was some other type of thing we did with XY chart where we had to fill in the Y's first.
Yeah. It might have been this, because I know, I probably teach in Algebra 2 and Pre-Calc. I remember teaching in Algebra 2, honestly, more than I remember teaching in Pre-Calc, so. Okay, so if I graph this, four, 1, 1, 0, and 1/4, -1. And so you have that curve, and remember the graph is running, I didn't draw that exactly right, down alongside the y-axis, never crossing, never touching. Okay. And then, so the idea is, if this was the inverse, and instead of 4 to the y equals x, but this was 4 to the x, then that's the one that would be over here. I didn't draw that exactly right, but okay, so inverses officially reflect across the line y equals x. Okay, sound familiar? Okay, next example. We're sketching y equals negative log base 4 of x. Thoughts?
So it would be that, but reflected over the x-axis, right?
Mm-hmm. Yeah. I remember if the negative is on the x, I reflect across the y. If the negative is just out front of the equation, I reflect across the x. So this is one way to think about, at least, is to think about reflecting across the x-axis. The other way you can think of it, if you are wanting an XY chart, we can't really do a left, right, middle when we have this negative on the log. So I can divide or multiply the negative over to the other side, and I can think about it as negative y equals log base 4 of x. And then I can do a left, right, middle from there. And so I could go 4 to the negative y equals x. To make that negative exponent positive, it's 1/4 to the y equals x. And basically, you'll just find all of your x values there's just going to be the reciprocal of them, isn't it? Okay. So if I sketch this graph, so instead of 1/4 -1, I'm going to do 4 -1. My 1, 0 is still the same. Instead of 4, 1, I'm going to do 1/4 1. And so it is reflected across the x-axis. Okay, so whether you think about as reflection, whether you think about it as an XY chart, it's all the same idea. Okay. 9. Assuming the b value is greater than 1, so assuming it's a positive base on these logs, graph the following on one graph. Okay, so we're going to do all one graph here. I'm going to draw my axes in the middle. X-axis, Y-axis, and really the main number I know I'm going to need is my ones. What was I doing last year? Why did no one catch me? I have X down here for the X-axis, and I put Y down here last year. And no one called me on it. I don't know if there's a reason I did that. I have no idea.
It's a special calculus.
I got nothing there.
It's like the x-axis and the y-axis. Yeah, once you get to calculus, they're actually the same thing.
It's just one of those things that's like, wow, no one caught me on that either. But who knows? For all I know, I could have been doing this in an empty classroom. Who knows? Okay. Although usually those I do on the iPad. Okay. So, y equals log base b of x. Log base b of x, what's a basic log graph looks like? It's what we drew up on A, right? It's going to run down along the y-axis. Typical, assuming no shift or anything, it's going to cut through 1, 0. And it's going to go over this way. That is my graph A. Okay, what about B? Which reflection? Okay, across the x. So across the x, x is a horizontal, so it's just going to flip upside down. So this one is still going to cut through 1, 0, but it's going to be running up along the positive y-axis, and it's going to be running over here underneath. So that's graph B. I'm color coding also, but I'm just, that way you can label which is which. Otherwise, you're going to have 4 graphs and not know anything about what's what. Okay, what about C? Okay, reflection across the y. The reflection of which one across the y? A, the original, yes? Because there's just a negative on the x. So now when we take A and we reflect it across the y, now it's going to cross through negative 1 and look something like that. Oops. That's my C graph. Probably see where this is going, but make sure you understand. What about D? Yeah, reflection across both axes. What color do I want to use? Hopefully my pink and orange look different enough, but I'll still label it D. So this one is taking the original graph A. It doesn't really matter the order of reflections, but you're reflecting over both, which means it ends up being in the diagonal quadrant, so to speak. And that is graph D. Okay? Know those reflections, right? Understand how those work. And you now I have a very pretty graph at least. But that's me and my color coding. Label them if nothing else, right?
Sophie Parton does not color code her notes. We had a whole conversation about it.
There's people in this room that don't color code their notes.
That's so weird. I color code all my notes. Even in pre-cal, I color code everything.
I don't really color codes in my try to use them occasionally.
That's so crazy.
Especially like if it's really important, I'll like underline it.
Wow.
That's it.
There you go. To each their own. I try and make mine pretty because they're going to be up here for all of you, and if you go back and look at them, but it doesn't always work. Some days they are a big hot mess, but it just depends. So, okay. And this says to graph the absolute value of the natural log of x on a graphing calculator. Now, I can't remember what the tricks are here. There might be a trick that we have to do. Okay, so do you remember even where to find your absolute value? There's one up in the shortcuts, actually. But otherwise, it's in the math menu. And I can't remember, do we have to use 2 absolute values? That's how we get that one. Okay, so I'm going to go based on what I have written in the notes and based on what the book has. Okay, so what happens when you just graph y equals natural log of x? Looks like a check mark thing? Now, think about this. What does the natural log of x look like as a graph? Looks like log of x, doesn't it? Can you guys see my dotted pencil there? Okay, that's natural log of x. Why does absolute value of natural log of x look like a check mark? Yeah, anything that's already positive, so what's up above the x-axis stays positive. Anything that was down below is now going to be up above, and it gets flipped up. We talked about that the other day, right? Now, that is if you're just using, if you did y equals absolute value of natural log of x. While we're here, what changes on your calculator if you do the absolute value of natural log of the absolute value of x? So if you use 2 absolute values in there. In other words, there's absolute value around, this is my natural log there, and there's absolute values around the x. What changes?
Yeah, I'm gonna punch this in wrong, but it looks like it does the same thing on the other side of the line. Yeah, it just
Double check mark, so to speak. Okay. In other words, it's taking the natural log of x over on this side and doing the absolute value. Now, what made that difference? We forced x to be positive. Technically, in a log, doesn't the inside of a log have to be positive? It does. And so what's happening is when you force x to be positive, now you end up with both sides. Okay. And officially it has, you guys realize it has the other side too, right? I just already have the other side drawn. Okay. So when you force that x to be positive, it gives you both sides. Which officially, in a natural log, it should be. Okay, what else do we have here? Okay. I'm ready to flip pages when you are. Sketch the graph of y equals negative log of base 1/4 x. Can you just think of what that's going to be? I mean, you can kind of think of like what negative does, but what's that 1/4 do?
would it be negative 1/4 to the y?
No, think of, so what I would encourage there, I had to process, I would say move the negative over to the y. So if we move and think of it as negative y equals log base 1/4 x, Because that negative in front of the log, we can't really do a left, right, middle with that. And so then what happens if I look at a left, right, middle? We end up with 1/4 raised to the power of negative y equals x. Well, that's what I figured. Yeah, it was just you ended up with the negative in the wrong spot. Now, how do we deal with the negative exponent? Reciprocal it, right? Now, we've already got a fraction inside of here. So basically, when you reciprocal 1/4, it becomes 4/1, which is 4. So we end up with 4 to the y equals x. Did we already graph this? Yeah, this is y equals log base 4 of x. Okay. And what it has to do with, if you notice on that one where we graphed all 4, it said the requirement was b was greater than 1. Because a typical log graph that does what we've been working with comes from below, cuts up through 1, 0. That's assuming b is greater than 1. What happens when b is less than 1? Well, that essentially works as another reflection. And so we had that reflection and then that smaller than 1 value, and they basically canceled each other out. Okay, so this right here, they end up being equal to each other. And so I guess it officially said sketch the graph. So if I throw the graph on here real quick. We're back to looking. Kind of a flat one, but it looks like that. And I think what would be helpful to know, we didn't officially graph it or anything, but it would be helpful probably to think about, okay, what does a basic graph of log base 1/4 x look like? And realize that looks like the reflection. So that looks like that right there. Okay, kind of a side note there. Okay. Okay, last one, I think. Y equals log base 2 of negative x. You can probably come up with some basics there. But if we talk an XY chart, let's confirm with an XY chart. Left, right, middle says 2 to the y equals negative x. Or if we're trying to make this equation x equals, we can say negative of 2 to the y. Dang it. Totally just wrote that wrong. Negative 2 to the y equals positive x. I think there's some football boys out there getting rowdy. Okay. So you could also think of it as the negative 2 on the 2 to the y equals x. And so again, y is in the exponent. So if we pick our y's as negative 1, 0, and 1, well, negative 1. The negative of 2 to the negative 1. 2 to the negative 1 is going to be 1 over 2, and then it's the negative of that out front, so negative 1/2. The negative of 2 to the 0. Negative 1. The negative 2 to the first. Negative 2. So, negative 1/2, negative 1, negative 1, 0, negative 2, 1. Looks something like that. Okay. It's not that calculus has a big focus on logs. It's just a matter of we need to be familiar with when logs do randomly pop up. Okay, because they do randomly pop up for various topics, various things. When we learn derivatives, integrals, we'll talk about logs. So, okay. Got what you need there? So we will set homework for problem set 12 is due on Monday.